This code uses system calls to figure out the performance metrics of the system and then log those in a text file that is given. The import psutil module provides an interface for retrieving information on system utilization, that is CPU, memory, disk networks, and sensors, along with system uptime. The import time module provides various time-related functions such as related to logging and such, so on. The logging module defines functions and classes which implement a flexible event logging system for applications and libraries in text format. The system metrics functions are those given below. From these, the CPU usage returns the CPU usage percentage to get the CPU over an interval of 1 second. The next function is which is called def get memory usage. This is used to get the system's virtual memory usage statistics and returns a percentage of used memory. The disk usage function similarly gets the disk usage statistics for the root directory and returns a percentage of used disk space. The network usage function gets the network I/O statistics and returns the number of bytes sent and received. This is the logging configuration. Configuration. It configures a logging module to log messages to a file named system-monitor.log, which is saved in text format. The logging level is set to info, meaning it will capture all messages at this level and above. That is info, warning, error, critical, for example. The format specifies how the log messages will be displayed, including the timestamp, that is AAC time, the log level, that is level name, and the actual log message, which is given in the which is given as percentage message here. Then there is the log metrics function. This function retrieves current system metrics using previously defined functions and logs them using the logging module. The logging module stores values under CPU usage, memory usage, disk usage, and network sent, along with network sent and received bytes. The def monitor module continuously monitors the system metrics in an infinite loop. It retrieves the current CPU, memory, disk, and network usage. It prints the retrieved matrices to the console. It waits for 1 second before repeating the process. The main block checks if the script is being run directly and not imported as a module. So if so, it calls the monitor system file function to start monitoring system metrics. As a summary, the script uses psutil to gather system metrics, that is CPU, memory, disks, and network. It logs these metrics to a file using the logging module. It continuously prints the metrics to the console in a loop, updating every second. The next one is a file called GUI.py. GUI.py uses the previous system logging metrics to form an application of which GUI is given. The imports given which are given are psutil, time, tkinter, ttk, and login. The time module provides various time-related functions. Tkinter provides tools for creating a GUI, that is a graphical user interface. TTK is a module that provides themed widgets for Tkinter. The logging module defines functions and classes which implement a flexible event logging system for applications and libraries. This is a system monitor class. We define this class so that it inherits from the module TK, base class for creating the tkinter window. The _init_ method initializes the window with a title and size and calls methods to create widgets and update the metrics. This is the create widgets method. This method creates 4 labels using the ttk.label to display CPU usage, memory usage, disk usage, and the network usage. The pack method arranges the labels in the window. The update metrics method. This method retrieves system metrics using psutil. It updates the text of each label with the current system metrics, and it schedules the update metrics method to be called again after 5000 milliseconds, which is 5 seconds, using self.after. The logging configuration configures the logging module to log messages to a file called system-monitor.log. The logging level is set to info, meaning that it will capture all messages at this level and above. That is, info, warning, error, and critical. This format specifies how the log messages will be displayed, including the timestamp, which is given as AAC time, the log level, which is given as a level name, and the actual log message, which is given in the form of message. Next is the log metrics function. This function retrieves the current system metrics using a helper functions, which is not defined in the provided code, but implied from the previous code, and logs them using the logging module. Uh, the underscore name equal to main is given as the main block. This block checks if the script is being run directly and not imported as a module. If so, it creates the instance of system monitor and starts a tick-inter event loop with app.main loop, which keeps the window open and responsive. The main.py function can be run, providing an insight on how the system calls the given CPU usage, memory usage, network usage, and disk usage when every 1000 milliseconds, that is 1 second.